So the last one we have is the lemniscate, also sometimes called the lemniscate. The root, fun fact of this word, means infinity, which will make sense in a little bit. So the rule I showed you about how to know where to start these graphs in general applies, or is in general the same as the rose curves. So sine doesn't start, when I say start, the maximum point isn't at 0. The maximum point would be located at pi over 2 times 2, or pi fourths. And it will always be 2, so it'll always be at pi fourths. For cosine, the maximum will always be at 0. Theta equals 0. Okay, so we've got a sine function. So I know if I plug pi fourths in, I'll get my maximum value. So what is that maximum value? Well, the maximum on the unit circle is 1. So this would just be r squared is 16, or you would get r is positive or negative 4. Let me show on the reference graph where you can actually see that though. If I graphed r squared equals 16 sine of 2 theta, you would get the following graph on the Cartesian plane, where theta is your x-axis and r squared is your y-axis. And this is 16 and this is negative 16. So notice pi is right here in the middle. And the first time you get your maximum of this graph is at pi fourths, which is exactly what we discovered over here. Now there are parts of this graph that actually you go into the imaginary plane. So when you see it graphed, it does some weird things. That's because at points it goes to imaginary numbers. So between pi halves, and pi, you'll have your imaginary numbers. And the reason it's imaginary is because r squared, if you set r squared equal to a negative value, so like negative 16, you'll end up with imaginary numbers. So this other side would also be imaginary. So there are times where the graph just kind of stops. So we have 0, zeros are starting. So 0, 0. I'm going to go a little faster on this than we've done in the past problems. We know at pi fourths it goes out to 4, and technically since it's r squared, you have positive and negative 4. If I just did the positive 4 and just graphed this portion though, like it was positive, really, I mean, you're graphing 2 parts at once, but I'm just going to graph it as if I'm doing one. I would start out like so, and then loop around and come back to the pole. And then on the other side, like these right here, I'd do kind of the same thing. So I'd start at the pole, and I would go out like so, and then come back and reconnect. And this is why it's called the infinity symbol, because if you look at it, or lemniscate comes from the word infinity, something that means infinity, because these look like infinity symbols or figure eights. Okay, so the cosine one, let's see if we can do it the quick way. But once again, if you need the table, plug in points. But the quick way, I'm going to go ahead and find my length. My length would be the square root of 9, or 3. So right here. And I know I was at 0 because remember you max out at 0. So I went out on 0. So that's my starting point since it's 0, 3. And eventually I have to go to the pole. And we eventually have to have our negative value as well. Or just on that side. So I just draw this like so. And you've got your cosine.